Good day, friends. Today I'll be talking about 17 equations that changed the world. It all started with the book by Professor Ian Stewart, Professor Emeritus, University of Warwick, England. In his book, he listed 17 equations that, as per him, has profound impact on our civilization. He listed them and he talked about them in his book. So let me start with the equation. We start with Pythagorean theorem, a square equal to b square plus c square. The area of the square on the hypotenuse is sum of the area of the squares on the other two sides for the right angle triangle. That's a simple theorem. Pythagorean theorem helped us create better maps. We use this theorem to find the shortest distance, which is useful for architecture, woodworking, or other physical construction projects. I think Egyptian used this theorem to build the pyramids, but I am not sure about this. Surely that is before Pythagoras. Logarithms, turning log a into c equal to log a plus log c, turning big multiplications into additions. Logarithms helps us perform tedious calculations. Before that, there weren't any calculators. They are especially evident in science and measurement. We always use algorithms. We always use logarithms when we talk about small and large numbers. For instance, when we work on our sensitivity to light, earthquake significances, noise levels in decibels, acidity, pH, money growing with a fixed interest rate, bacteria growing in a petri dish, and radioactive decay, we use logarithms. Then come calculus, DFDT. This is the definition of the limit of a composite function f composed with g. Limit h goes to 0 f g t plus h minus f g t by h. Calculus helped us turn away from mysticism and alchemy to rational science. It appears everywhere in modern science and technology, whether we are modeling the stock market's rise in fall or determining exactly when a space rocket will arrive in Earth's orbit. Calculus created the modern world, and it holds incredible power over the physical world by modeling and controlling systems. That's calculus. Then number 4, Newton's law of gravity. The gravitational attraction between two masses m1 m2 is given by m1 multiplied by m2 divided by r square, where r is the distance between them and g is the gravitational constant. Newton's law of gravity helps us understand the movement of stars and planets. Understanding the divine force, momentum, and many other laws is the key. Then we go to number 5, complex number I square equal to minus 1. The square root of minus 1 was invented to solve equations that have negative roots, and most of our modern tech depends on them. Although many people hated complex numbers, I square is a great discovery and had a lot to do with the development of quantum mechanics. It brought up ideas that turned out to be very important. So our mathematics is useless without complex numbers in today's life. Euler's formula for polyhedra. For a solid polygon, number of vertex plus number of faces equal to number of edges plus 2. Euler's formula helps us send rockets throughout space and understand DNA replication, an essential ingredient in finding solutions for network information. Euler's invention is a new way of thinking about shapes and space, and it also provides a clear connection between geometry and not structure of DNA. So lots of applications of Euler's polyhedra formula. The normal distribution, it comes in statistics, fx equal to 1 by root 2 pi sigma square e to the power x minus mu whole square by 2 sigma square. Normal distribution transform how we understand medical trials and gambling and change almost all the psychological and educational applications of our modern world. Statisticians and scientists use normal distribution to measure reading ability, job satisfaction, surveys, IQ scores, blood pressure, measurement errors, etc. So normal distribution came up from theory of errors by Carl Friedrich Gauss. Wave equation. It tells us what the earth is made of and helps us find oil easier. It is essential in electromagnetism, optics, fluid dynamics, and heat transfer. Also, it lets us predict future dynamic properties such as energy and impulse. That's wave equation. Number 8. Number 9. Fourier transform. You see this post thanks to the algorithm because the internet, Wi-Fi, smartphones, computers, routers, and almost everything that has a network inside uses Fourier transform algorithms. Fourier transforms are essential in signal processing, and we can now compress thousands of information in a tiny dongle. That's Fourier transformation. Navier-Stokes equation. The Navier-Stokes equation is significant in terms of pure science and mathematics. The equation represents the governing equations of one fluid flow model, and the equation also tells us all the fast things in life that can go even faster. That's number 10. Number 11, Maxwell's equation. All modern wireless communications that we have today are related to Maxwell's equation, and those equations are mathematical summary of electromagnetism. It came up from electromagnetism, the study of electromagnetism by Maxwell. Second law of thermodynamics. It drove the industrial revolution and gave us efficient power generators. It also represents the relationship between heat and energy. For instance, it explains what happens in our cup of tea if we don't drink for 5 minutes. That's number 12. Number 13, relativity equal to mc square. The relativity theorem is very important because it previously answered almost all the questions that remain unanswered and changed the way we look at the time, space, and gravity. It is everything for black holes, the Big Bang, nuclear power, and GPS in our phone. In GPS, we have relativity correction, without which GPS can't be accurate. Number 14, Schrodinger's equation. This theorem changed the field of quantum physics and made it possible to work on quantum and calculate what would happen next. It also essential for modern computers, chips, and lasers and CATs. Information theory. This is the calculation of entropy minus x belongs to s, pxs log pxs. Information theory means internet and it models the human-machine communication process, and the theory is now more important than the communication itself. It is going to AI, building robots, etc. Number 16, chaos theory. Xn plus 1 equal to Rxn into 1 minus xn. Chaos theory helps us predict the weather better. It's the butterfly fault for flapping its wings, and the equation also predicts the growth rate of butterfly population. So that's chaos theory. And the last one is Black-Scholes equation. This equation models the massive growth and profits of the financial sector. Some people believe that the Black-Scholes equation caused the financial crisis of 2008-2009. That completes 17 equations. Here is a list of them. I'll stop here. Thank you.